In this lecture, we'll be discussing how to appropriately apply the t-test methodology within IBM's SPSS statistics. And this is probably one of the most common methodologies which is utilized within the field of statistics, and probably also one of the most important methodologies as well. So I'm going to assume that you have some exposure to the t-test methodology and some understanding as to when it's appropriate to apply. And in this particular lecture, we'll be discussing, as far as SPSS examples are concerned, the two-sample t-test, the paired t-test, the Welch's two-sample t-test, and the summary independent samples t-test. And as always, the code for this video, along with any associated data files, which are structured in CSV format, can be found within the video description below. So we're just going to go through a couple examples. I'll show you how to run the analysis, and I'll show you how to report your results in the APA format. So we're going to get started with a basic two-sample t-test. So in this instance, we have a scientist who creates a chemical which he believes changes the temperature of water. He applies this chemical to water and takes the following measurements. He then applies temperature in samples which the chemical was not applied. Can the scientist conclude with 95% confidence interval that his chemical in some way is altering the temperature of water? So we have two samples. So this is going to be a two-sample t-test. These are of equal size as far as the samples are concerned. And because we're looking for a significant difference, we will be utilizing a two-tailed t-test. So here is our hypothesis. The null is the chemical is not altering the temperature of water, and the alternative is the chemical is altering the temperature of water. So let's go to SPSS and go from there. So here's our data, which again can be found in the video description below. And I have labels on the observations. So you're going to need to go ahead and put these labels on yourself. But as you can see, in every instance where we have a 0, it's labeled as no chemical. And for every observation instance where we have the measurement of 1, we have the label of chemical. So let's get this show on the road and get this two-sample t-test methodology applied. We're going to go to Analyze, Compare Means, Independent Samples t-test. Independent Samples t-test. Let's get these out of here so we can start afresh. Temperature is going to be our test variable. And then the categories are going to be C application, or the application of the chemical. Now, as you can see, C application has labels of 0 and 1, as was mentioned earlier. So we need to define these groups. So I'm going to go ahead and click Define Groups for our categorical grouping variable. And we're going to select 1 for group 1, which was the application of the chemical, and 0 for group 2, which is the non-application of the chemical. And then we're going to click Continue. Now you can go ahead, if it's applicable to your research, and use the Options button to change the confidence interval percentage. Remember, your confidence interval is going to be 1 minus your alpha value. And if it's a value which is not 0.05, your alpha value, you'll have to change your confidence interval to whatever value is applicable. But ours is 95%, so we're good to go. Everything has been entered appropriately, so we're going to click OK. This is the output that we receive in the output window, and I'll show you how to break this down in APA format. So let's minimize this. And let's take a look at our output. I've underlined all of the values which are relevant to reporting our results. So there was a significant difference in the temperature of water prior to the application of the chemical. Here we are, no chemical. Standard deviation for no chemical. As compared to the temperature of the water subsequent to the application of the chemical. Here it is with the chemical. There's the mean. There's the standard deviation. We then need to put our degrees of freedom, which is 14. Our T value goes here, and then our P value. And we're rounding everything to 2 significant figures. So there was a significant difference because our p-value 0.03 is less than our alpha value of 0.05. So when the p is low, the null must go. So let's move now to the paired t-test. Okay, here is our paired t-test example. A watch manufacturer believes that by changing to a new battery supplier, that the watches that are shipped, which include an initial battery, will maintain a longer lifespan. To test this theory, 12 watches are tested for duration with the original battery, and the values are below. And then the same 12 watches are then retested for the duration with the new battery. Can the watchmaker conclude that the new battery increases the duration of lifespan for the manufactured watches? We'll assume an alpha value of 0.05. So in this case, we have the same 12 watches each time. We have the watch duration as it pertains to the initial battery, and then the watch duration with the new battery. So same watch, old battery, new battery, old battery, new battery. Alpha value of 0.05 means a confidence interval of 95%. An increased duration is a one-tailed t-test, a right-tailed t-test. So here is our hypothesis. The null is that the new battery does not increase the duration of the lifespan for the manufactured watches, and the alternative is the new battery does increase the duration of lifespan for the manufactured watches. So let's go now to SPSS and apply this methodology. Here we are. So we're going to go to Analyze, then again to Compared Means, and then Paired Samples t-test. All right, so we're going to be working with the variables old battery and new battery. We're going to put new battery as our var1, our variable 1, and the reason we're doing that is because this is our sample mean. Okay, and our old battery is going to be variable 2 because this is our hypothesized mean, or the mean of the initial sample. Options, again, will allow you to change the confidence interval, but because our alpha value is 0.05, we're going to leave this be, and we're going to leave everything else, the default, selected as well. Once that's complete, we're going to click OK, and here is our output. I'm going to return now to PowerPoint so we can discuss what our findings were and how to report them appropriately in the APA format. So here's our output, new battery, old battery. And so we can say, based on the p-value, there was a significant increase in the lifespan duration of watches which contained the new battery. Here's the mean for the new battery. Here's the standard deviation for the new battery, as compared to the lifespan of watches which contained the initial battery. Here's the old battery's mean. Here's the old battery standard deviation. Remember, two significant figures, okay? Here is our degrees of freedom, 11. Here is our t-value, the two significant figures, 2.46. And here is our p-value. We're going to round that up to 0.02. 0.02 is less than our alpha value of 0.05. So because the p is low, the null must go. And there we will state that there was a significant increase. Now, the reason we're using one-sided p here is because we're looking at a test which is one-sided to the right. And if we were looking just for a significant difference and only a significant difference, we would use the two-sided p. So if we're looking for a significant increase or decrease, it's one-sided p is what we're going to be looking at as it pertains to our p-value and our corresponding hypothesis. And if we're looking to see if there is a significant difference, not a significant increase or decrease, but a significant difference, we would look at the two-sided p-value. Okay, and that would be the value which we report in our findings. Which brings us to the Welch's two-sample t-test. So you might notice something is a bit different here than it was in our initial sample or our initial example as it was. In this case, our scientist is applying, again, the chemical to water and he's taking measurements. But as you can see, for the second sample here, we have an instance in which we have less observations with the chemical applied than for the chemical not applied. Everything else is the same. We still are using a 95% confidence interval, and we're still looking for the chemical in some way altering the temperature, which is just a significant differentiation, not an increase or decrease. So therefore, a two-tailed t-test, which gives us the same hypothesis. The chemical is not altering the temperature of water, or the chemical is altering the temperature of water. But watch what we're going to do differently in this instance. Again, we're going to go back now to our SPSS and apply this appropriate methodology. So let's go to Analyze. We're going to go to Compare Means again. We're going to go to Independent Samples t-test. And let's clear these out. And in this case, because we're using a new variable set, we're going to select wTest as our test variable and wApplication as our grouping variable. And we again have to define the groups. We're going to use 1, which is the application of the chemical, and 0, which is no chemical application. And we do that because we have labels on our observations. Options would allow us to change the confidence interval if necessary, but still unnecessary because our alpha is 0.05. So we're going to go ahead and click OK now. And let's take a look at what we've got going on here. I'm going to now return to our slides. So what we're going to do in this case is we're going to report everything as it was in our original data. Obviously, the mean and standard deviation are going to be different because there's less observations for the chemical application. However, when we're reporting the t-value, the degrees of freedom, and the two-sided p-value, we're going to be operating under the pretense that equal variances were not assumed, meaning that instead of running a two-sample t-test, we're utilizing a Welch's two-sample t-test. So make sure in your methods section when you're discussing what sort of methodology you're applying, you're not applying a two-sample t-test, you're applying a Welch's two-sample t-test. And a Welch's two-sample t-test is what you're going to use when equal variances are not assumed. And typically, equal variances will not be assumed when one observation sample is greater than the other. So if you have a situation, again, where one sample is larger than the other in observation size, use equal variances not assumed in the output. And this would be deemed a Welch's two-sample t-test. Everything else is the same. It's just a Welch's two-sample t-test, equal variances not assumed. So just in your methods section, say, I utilized a Welch's two-sample t-test, And then when you report your findings, there was not a significant difference in the temperature of water prior to the application of the chemical. There's the mean, there's the standard deviation, as compared to the temperature of the water subsequent to the application of the chemical. There's the mean, there's the standard deviation. And then we jump down here. Here is our t-value, 2.01. Here's our degrees of freedom, which is 11.937. We round it to 11.94. And our p-value is 0.067. We round it to 0.07. Now, I often get questions because people will, do their own research as it relates to whatever their data set may be. They apply the test appropriately and they have the output which is appropriate as it relates to their data. And they might get a value in which their t-test is negative. So instead of 2.011, they might have negative 2.011. And instead of 1.900, they might have negative 1.900. Now, a positive t-value is going to reflect a sample mean larger than the hypothesized mean, and a negative t-value reflects a sample mean smaller than the hypothesized mean, which is why when I'm running these method applications, I always have the application versus the status quo. And that's why we have a positive t-value, because the sample mean is larger than the hypothesized mean, meaning that the most recent sample is higher than what we're comparing it to initially. Okay? All right, so now we're going to do a summary independent samples t-test. Same sort of application. But in this case, we're going to pretend that you don't have these values. We'll say that you're in a class and this is what you're given. Instead of being given the actual observation values, you're just given a summary of those values. You're given the number of observations, the standard deviation as it pertains to those observations, and the mean of the observations in each instance. Still utilizing a two-tailed t-test as the question has not changed, but with this information presented to us, without the observations themselves, with a summary of the observations as it relates to each category, how would we proceed to analyze this information and come up with the appropriate conclusions utilizing SPSS? So first, we're going to state our hypothesis, that being the chemical is not altering the temperature of water, the alternative being the chemical is altering the temperature of water, and then we're going to proceed appropriately in SPSS. So let me get SPSS back up. Come on, SPSS. I know. There you are. So in this instance, we're going to go to Analyze. We're going to go to Compare Means. And we're going to go to Summary, Compare Means, Summary Independent Samples t-test. And here we're going to put the values for the chemical applied. So there was 8 observations. Mean was 75.25. Standard deviation was 1.67. And for the chemical not being applied, 8 observations, 72.88. Standard deviation 2.17. Confidence interval is still 95% because our alpha value is 0.05. So once we have this entered, we will click OK, and we will receive the appropriate output in SPSS, the corresponding output, and we can then report our findings. So this is what we're looking at here. Here's the chemical applied. Here's the chemical not applied for the mean, for the standard deviation. We're going to assume equal variances because our sample sizes were the same. We have our t-value, our degrees of freedom, and our p-value, which is less than 0.05, and we're going to round each of these values to 2 significant figures. And we're going to state our findings. There is a significant difference in the temperature of water prior to the application of the chemical as compared to the temperature of water subsequent to the application of the chemical. P equals 0.03, which is less than our alpha value of 0.05, so the P is low, the null must go, and that is it. So that's where we're going to end today. If you enjoyed this video, please consider liking and subscribing. If you have any questions, maybe leave a comment so we can all help one another out. We're trying to get the message out to as many users as possible, so best of luck in your research. Thanks for stopping by, and until next time, take care.